Welcome everyone. We're back on this segment discussing namespaces, which this time is a C++ feature that's important to understand. So it's a key concept. We already alluded to their role. They're a bit like packages in Java. So I'll show you an example of using them and what happens when we change the way we do the inclusion. So think of a namespace as a group of entities that are cohesive for some reason. For example, they're all related to I/O, or they're all related to graphs. They form a module in essence. And they can contain constant, variable, function, structure, classes. You can even nest namespace. It's perfectly easy to do. And you can, from within any namespace, you can make use of object defined in another namespace, exactly like you can with the import directive of Java. So we'll see how we do that in C++. And of course, once again, I'm going to make use of my trusty little Hello World program to show what is happening when I change my definition. So if you recall, and that's where I will start, with this example, if I simply go and switch to my compiler, when I compile this hello1, everything works the way we would expect, and we got an executable which we can run, right? So hello1 executes without any trouble. So let me go back now here and say, for kicks and to see what happens, I omit an std and I just say cout. So now it basically means that this program is expecting to find cout defined in the main namespace. There is always one, that's the global namespace, and here it says the function main goes into the main namespace, and I'm expecting to find cout in the main namespace. So of course, the way I've described this to you is that the standard template library does not place a cout in the main namespace. So this cannot work to our satisfaction. So if I try to compile this, I get back an error. Now, the message may look a little long, but it's full of very nice explanation. He's telling us in line 5, column 4, we have an error because there is an identifier that's undeclared. And he tells you who that is. That's cout. And even say, oh, didn't you mean std cout by any chance? I suspect you might have made that mistake. And then he shows you the line in question, points with this little ASCII art, he points to the name cout, saying this is the place where I would have expected to see maybe std cout. So he has a good guess as to what is wrong with your code, but he doesn't give any more insight. And he even give you the justification of why he thinks this is the right thing. That's because he noticed that using the tools of the compiler, he figured out that there is an std cout that's defined inside something, and here is the place. He shows you the place of the definition. That's maybe too much information for now, but at least there is a clear indication that we didn't make correct use of the namespace. So we can, of course, compensate and try to fix this by actually using the correct name. So as you've seen, I have the freedom of simply qualifying, saying std colon colon, and if I had several nested namespace, say ABC, I would go A colon colon, B colon colon, C colon colon, and then the name of the object. So I can nest them perfectly fine with this notation, and I can refer to the name. But you're probably thinking by now, oh my god, this is an awful lot of typing. I have to say std cout, std nline. I'm typing 10 characters for doing something that's completely straightforward. Well, there is another way to include the namespace, and that's with a using statement. So let's take a look at that. Here is the example. So I don't want to do this typing, so I'm going to remove it. And I don't want to do this one either. So I take both out. But the problem now is that both are an issue. I want, though, to still have access to the std namespace. And the way to achieve that is with a stanza that states, by the way, from this point on, within the function main, I want to have all the object available in that package, in that namespace, available to me. So you do that with using namespace, and you see that Emacs is nice. His syntax scholars to say, oh, I understand that syntax, std. By adding that statement, saving, then going back into my buffer to compile, and running the compiler again, this time no error. No error whatsoever. I can execute the code, and I will get exactly what you would expect. I will get hello world. That's my normal behavior. So that's quite easy to do. Note that this using stanza is valid within the main function. The moment we're here after the main function, all bets are off. We're no longer stating what to include. And if you try to write another function that also uses cout, you would have to once again state using namespace std to actually make use of cout within that function. And you're probably thinking, well, we're back to square one. I mean, if I write 10 functions in my files, which is perfectly valid in C++, this is crazy because each and every single functions or method, I'm going to have to do that. Well, thankfully, that using statement, you can actually put wherever you want. You can even put it at the top level. See here now, I'm putting it before the function main, which means that for the remainder of the entire compilation unit, the namespace content is available to you. You can actually make use of cout or nline without further ado, right? And once again, we save this file, we go in the shell, we try to compile, and everything works the way we expect it to. So this is quite easy to do. You can define or make use, rather, your namespace in two ways that are completely transparent, either with an explicit naming of the entity you want to reach, or using namespace stanza to actually bring into your current namespace the objects that you want to make use of. Now, the last thing we may want to do, and it's a little bit of fun, I'm going to say that there is another function, and I'm going to say that this is a function that returns a number. It's not important how it does it and what it does, but we'll say, oh, I want to have a function foo, and it takes a number n, and what it does is that it simply returns n plus 1. So a totally boring function, and I could make use of it here by saying, oh, after printing hello world, I'd like to actually output the value of foo10. Right? So this is a valid program. Now notice that I already show you, hey, I'm reusing my output operator and I'm chaining three output. I'm outputting the string, I'm outputting the result of the function call, and then I'm outputting end line, which sends a carriage return line feed. I'm outputting the three things back to back as a sequence, and the foo function definition is up here. Oh, I notice I have a typo to fix. This is a foo function that defines a name n, takes that as an input, add 1, and returns that. Okay? So we can clearly make use of that program. Let's switch buffer, compile, and run. And no big surprise, it's a hello world 11. Okay, why am I doing this? Because now I want to say, oh, but you know foo, I mean, everybody's going to call their function foo. It's not a very good name, and you might think, oh, but there is a solution to that. This is something that I'm doing in the context of the class 3150, so I should put it in a namespace, right? And to do that, we can define namespace CSE3150, that's the name I'm going to give to that namespace, then a curly brace, and I put my function inside. You notice that simply because I like to have very clean and tidy code, I reindented the content of the namespace. So now foo is a function exactly as before, but it is in a specific namespace, and main is actually working. So you might think, is this going to work, right? That's the first thing. I've just packaged the function inside a specific namespace. What happens if I try to compile that? You get an error. You wonder, well, what is going on here? And he tells you, well, same as last time, right? He says undeclared identifier, foo, and he says, did you mean by any chance CSE3150 foo? Because he noticed that there is a foo in a namespace, but you didn't import it with a using namespace stanza. So he's unable to actually make use of this, and he won't let you do that. And he even tells you where this is happening and where the thing was defined. He tells you where foo was defined, exactly like last time. So the way to use that, of course, there are two ways. It's either the direct way, and I could say CSE3150 : foo. That's my first option. Now I'm going to make this really tidy. I indent the line, recompile, and this time everything worked. Rerun. and you get the expected behavior. So, simple idea. Of course, I can still use my using namespace STD3150. That's going to work as well. But in this way, I can actually get the proper behavior and include the concepts as I go. To sum up, let's go back to the slides. To sum up, my namespace allows me to actually use multiple mechanisms to include them, fully qualify name using the double colon notation, local imports that you put within a function, and then within that function, those namespace that you have imported with using namespace are available to you, or a global import that you put at the top level of your file, which means that for the rest of that compilation unit, the content of the namespace is indeed available to you. So these are the 3 ways to do the inclusion. We've already shown the example, so we're good to go on this. And at this point, all I have to do is tell you, see you next time, and we'll be looking at IOStream in further details.